is Robert Alcorn. You can call me Bob. I'm a software engineer with AWS Cryptography and Privacy, here to talk about IAM Roles Anywhere. I have a colleague from AWS, Mohammed Keshk, the product manager, and a couple of colleagues from Hertz, and they're going to talk about their experience using Roles Anywhere, Stephen and Rudy. So before I go on, I'm going to tell a brief story. So before coming to AWS, I was actually a customer. And I was in charge of cloud operations and architecture for an ed tech firm. And we started small, like most organizations do. We started building up US East 1, had some accounts, built some applications, following the well-architected framework as best we could. But the reality was we had a pretty sizable data center operation. And then we had a couple of acquisitions, and those acquisitions came with data centers. And the workloads running in these data centers were things like ETL processes that were pulling data from legacy databases. One arm of the business was actually doing marketing, so they had these farms of MTAs. And we also had pipelines based on Jenkins that would actually deploy AWS services, right? This sounds familiar to everybody. And as the cloud architect, I had to figure out how do all of these services interact with AWS? How do these Jenkins pipelines create the CloudFormation stacks and so forth? And so I did what I expect most people do. I actually created IAM users, and I distributed access keys and secrets. And then I tore my hair out because I was spending so much time trying to make sure that they were delivered securely, that they were rotated, and that they weren't otherwise compromised in some way. So that should be a common experience for everyone here, or might be, maybe not. And what we're going to talk about today is IAM Roles Anywhere, which is a solution from AWS to help mitigate some of that pain. So I'm going to talk about what it is, how it works, talk a little bit about workload identities, which is what you have to think about when you start worrying about authenticating and authorizing these applications that are running off of AWS. We're going to talk about how that relates to access control and traceability. And then I'm going to invite up these colleagues from Hertz to tell you their experience using Roles Anywhere. And then we'll look forward at some of the roadmap coming. So at its core, IAM Roles Anywhere is a mechanism to use temporary AWS credentials from outside of AWS. And I'm not talking SSO. I'm talking about the same way when you're in AWS, you run an EC2 instance, you get an instance profile and a role. You run a Lambda function or an ECS container. That compute has credentials that are provided to it by AWS. So we do the same thing with Roles Anywhere, leveraging PKI X509 certificates, so that your servers, your containers, your applications that are running in your data centers or off AWS can use IAM roles and policies the same way that they would if they were in AWS, and do this seamlessly through SDK integration. So at the core, you start with Roles Anywhere by establishing trust. I mentioned PKI. So what you'll need is a certificate authority. It can be an AWS private certificate authority. It can be something you're running on-premise, like Active Directory certificate services. You take either the issuing certificate or the root certificate, and you upload it and create a resource called a trust anchor. Then you configure your roles. So you have to have on your role, if you've done instance profiles or Lambdas, you know that you have to trust the service to issue credentials for that role. So you have to add Roles Anywhere as the service principal for the trust policy on the role. You also create a resource called a profile. And a profile is, one, a pointer to that role, but two, it's also a mechanism to add additional policy constraints. So when you have a role, you have policies attached to it, but you might say, hey, when I'm using this role from my data center, I want to enforce network restrictions. I only want it to come from the IP addresses that I know are the egress from my data center. So you can use the profile to do that. Finally, you set up your client to use it. And as of today, we provide a helper tool. We call it the credential helper that you configure on your compute, and it will interact with IAM Roles Anywhere to use the certificate that you've issued to the compute as well, a private key and X509 certificate, to get the temporary credentials. And what that looks like is this. So you have your server, your container, your applications running in your data set. You configure the credential helper with all of that information I mentioned earlier, the role that it's going to assume, the profile that we use for additional session policies, the certificate you've issued to the compute and the private key, and the trust anchor, or that root of trust I mentioned earlier. The credential helper calls Roles Anywhere. There's an API method called create session. Roles Anywhere validates the signature that was provided, that was generated from the private key attached to that certificate. It verifies that the certificate was in fact issued by the trust anchor and not revoked. It reads the profile to get any session policies to attach to the role. It then calls SCS, assume role, on your behalf, and returns those credentials to the compute. And there are a couple of different mechanisms. You can configure the SDK to use the credential helper, but ultimately it's transparent, and the SDK can then call any other AWS service. If you need to write data to S3, invoke a Lambda function, use KMS to encrypt or decrypt data, et cetera. So when you configure the credential helper and you issue these certificates, one of the key things that you'll have to reason about is the identity of all of these processes. Now, before I go on, just show me who uses the word workload on a day-to-day basis. Okay, right? I think we use it a lot. We use it kind of fast and loose, but who thinks they can actually define what a workload is? Right, nobody raised their hand. So this is the definition that's provided by the AWS well-architected framework. And what I want you to realize from it is that it actually is kind of helpful but vague at the same time. And what you can do with it is you can reason that, well, it's any related set of compute, right? It might be everything in an application, but that application might have many different components to it. It might have the code that's running the ETL that's going to be writing the data to S3. So it's a flexible term in that you can apply it to different levels of granularity and abstraction. So don't focus on the contents of this diagram, right? I picked a diagram at random from the well-architected website to make a point that if you looked at this, what would be the workload, right? You have lambdas, you might have containers, you might have stuff running on AWS. In your data centers. So one of the things that when you're designing your Roles Anywhere deployment, you'll have to think about is what am I actually identifying? So on screen here, I have the output of what you might get if you ran SSL, OpenSSL, to look at the contents of a certificate. And certificates, as you may or may not be familiar with, will have a lot of different fields in it, right? They'll have information about the CA that issued it, or they'll have information about the validity period, the expiration. But what I'm going to call your attention to are the subject and the subject alternative name. And when we use TLS, for example, the subject is almost always, it's the host name, or it can be a wildcard or something like that. But what I'm showing you here is an example where we're actually encoding two different identities. All right, and this is not meant to be prescriptive. This is just a descriptive example to kind of give you some ideas about how to think about the certificates you issue for authenticating with Roles Anywhere. So the subject is actually referring to a specific host name. In this case, it's an ETL node, but I might have multiple of those, right? So if I'm authorizing, am I authorizing the 6 nodes independently of each other, or do I give them a shared identity? So in this case, I'm using a subject alternative name to encode a shared identity. And the example here is for something called SPIFFE. Is anybody familiar with the term with SPIFFE? So it's Secure Production Identity Framework for everybody. It's an emerging standard from the Cloud Native Compute Foundation. And again, not to be prescriptive, but to be descriptive, I find it useful because it gives you sort of a hierarchical representation. So back to the point about, is the workload the whole application or is it individual components? You can model it out however you want. So we have some kind of top-level trust domain, example.com. You have an identifier for the workload. In this case, it's workload, or the actual component. So I might have multiple servers essentially doing the same thing, and they would all authorize the same way. They would all present the same subject alternative name or workload identifier, even if they're getting distinct identities for the individual units of compute. And that's important because that lets you think about how do you build your access controls and your observability and traceability for these workloads. So to start, you might, in the assume role policy document, decide to create conditions that are based on these attributes. So in this particular case, I'm looking at the OU of the subject that's being asserted. And it will show up when the credential helper calls create session as a principal tag. So what Roles Anywhere does is it reads that certificate, looks at the subject, breaks the subject into all of its different RDNs, relative distinguished names, and maps each one of those RDNs to a principal tag. So a CN, common name for subject, or OU for organizational unit. And you can then write a condition that would say, I only want to authorize certificates with this particular identity, with this particular CN. So everybody from my engineering organization. The properties are also in the session transitively, which I mean that in two different ways, right? So once I've authenticated, the session I get back, if you're familiar with STS, you get a session token. All of those tags are in that session token. And so every time I make an API request, if I call S3 put object or get object, the same principal tags will show up and can be used to make access control decisions on resource policy, so on a bucket policy, for example. And they're also transitive in the sense that if I were to assume a second role, right, use the first role that has permission to call assume role and get a second role, the tags will carry into that chained role as well. The next area where you get benefit from this approach is in your traceability. So when you call S3 put object, we're taking information from the certificate and putting it into the CloudTrail record. So first thing, we take the serial number of the certificate and we encode it as the session name. So if you think about it, you have a certificate, you might be expiring that certificate every year, every 6 months, every 45 days, but the identity is going to be the same. What CAs do is when they issue a certificate, they encode a unique number. So that is the serial number for the certificate. So you can, in CloudTrail, identify the actions that were taken as a result of assuming a session from a specific certificate. We also take the CN, the common name of the subject, and we encode it as the source identity, which also shows up as the CloudTrail field. So you've got those two different identifiers, one for the credential, the certificate, and one for the identity that's encoded in that credential. So that gives you a couple of different ways where you can think differently about what am I actually authorizing? What identity am I authorizing for this server or this application I have in my data center? I might be encoding the actual host name. I might be encoding an abstract identifier that says this is the collection of all my ETL nodes. And at the same time, you have the flexibility to audit based on what certificate they used. So if you need to trace what happened because you think a key has been compromised, well, you know what certificate it was, and you can go through and look at all the actions that were taken as a result of authenticating with that certificate. So I hope that gives you a sense of the service itself and how you can think about the certificates and authorization. And with that, I'm going to hand it to a colleague from Hertz, Steve.
Hello, everyone. My name is Steve. I am a principal cloud engineer with Hertz. So hopefully everybody is aware of all of this already, but just to give you a little bit of background on Hertz, we are one of the largest worldwide vehicle rental companies. We're currently offering the largest EV rental fleet in North America. We have a few different brands, Hertz being our flagship brand, and then Dollar Thrifty and our Firefly brands as well. We're currently located in more than 150 countries, and we are using AWS to support production workloads in 3 AWS regions spread across North America, Europe, and Australia. We're in about 400 accounts, and by the end of Q4 of this year, we should be extended into 6 regions. So I know this presentation is around IAM Roles Anywhere, but I feel it's worthwhile kind of talking about our current AWS footprint and what security controls within AWS that we're using to secure these various workloads. First and foremost, we have adopted a micro account strategy for all of our different applications within AWS. So what does this mean? This means that applications will go through an architecture review, a security review, and then once they are deemed to go into AWS, we give them a development account, a QA account, a staging account, and a production account. This really helps us with IAM controls, kind of limits the blast radius if something does get impacted in the account. And it's also, it's really good for kind of cost management, right? You can easily see what application, how much resources they're consuming, how much money you're spending. You can break it down by life cycle. So it just has a lot of benefits when you adopt this strategy. The service that we're using to do this is AWS Control Tower. We chose Control Tower because of kind of the baked-in security controls that it offers with the SCPs and managing the landing zone for you, and the account vending, right? It just makes it super simple to kind of deploy all these workloads quick. As far as the core business accounts, on top of the application lifecycle accounts, some teams have kind of business unit specific accounts where they'll create APIs that are shared across their applications. So we'll give them a core business account. And then on top of that, we have our standard security accounts, be it log archive, audit, networking, global, regional, shared services accounts. We do have a few security partners that we use to secure our workloads in AWS as well, but we try to stay as cloud native as we possibly can. We're currently using Security Hub at the organizational level. We use this for centralized compliance findings. We're running CIS 1.2 scans against all of our accounts, PCI scans, AWS best practice scans. We use AWS Audit Manager as well. This is a great tool for us. We primarily use it for PCI workloads, but basically on a monthly basis, we have Lambdas going off that are generating these assessment reports, storing them in S3, and also sending them out to our compliance teams so that our compliance teams on a monthly basis can look at these PDFs and provide them to auditors if they need be. We're also using GuardDuty, which is personally one of my favorite tools. We use it for threat detection. We're using it for EKS audit logging, RDS protection, S3 protection, Lambda, malware findings. So that's a really great tool. We're also using AWS KMS primarily for encryption at rest, and some of our application teams are also using it for JWT tokens. We use ACM for our public and private certificates within AWS. We use CloudTrail for all of our API logging. Again, we're doing this at the organizational level with a regional trail, and all of those logs are going to a central S3 bucket in our audit account. And I think it's worth mentioning too, all of our Security Hub logs, GuardDuty logs, CloudTrail logs, those are all going into Splunk, which our security team can use for analysis and aggregations for their daily workloads, right? And of course, we're using IAM for identity access and Identity Center for our SSO. So like a lot of large enterprises, Hertz is in the midst of a digital transformation. We're working on migrating our North American data center as well as our European data centers into AWS. And of course, all of our net new applications are going into AWS as well. Most companies are at different stages of their transformation. And a lot of our products that we use in our data center, they're kind of legacy applications, right? And our third parties we work with aren't always at the same speed that we are. So one of the key challenges that we ran into was providing access into AWS and providing those long-lived static credentials. So like I said earlier, we have over 400 accounts. So managing those static keys across those accounts can become very problematic, right? You're stuck with the overhead of managing rotation policies. Obviously, you have to be super efficient in your code scanning. You don't want developers putting these credentials into their code. You don't want them baked into servers, things of that nature. So these are just the problems that we have ran into. Luckily, the solution for us was to go ahead and use IAM Roles Anywhere. This integrated super easy with our on-premise data center systems. End users could just use the credential helper, download it, and authenticate into AWS with temporary credentials, and we don't actually have to worry about managing those static credentials. Also, the third parties that we work with, Salesforce being a key partner for us, using IAM Roles Anywhere with us has helped us out greatly. So there's a couple different steps as discussed earlier in the prerequisites for using IAM Roles Anywhere. One of them being how you set up your PKI infrastructure. What we decided to go with was a 3-tier PKI. Kind of the benefits of this are, granular security controls, delegated access to subordinate CAs, additional protection of higher level CAs, like your root, your intermediate and your root, right? And so, what does all this mean, right? Basically, it allows for the distribution of responsibilities, right? And kind of promotes a decentralized administration and delegation of certificate management tasks. It also helps with scalability, right? It supports speed in larger enterprises, allowing one team to kind of manage your root, maybe that same team or another team with your subordinate and your intermediate, and then your issuing CA can kind of be spread across to other teams, right? In addition to that, it also helps with, the containment and your blast radius, right, of potential compromise, right? So if you need to revoke a certificate, you can do that quickly, or, God forbid, your issuing certificate gets compromised, you can revoke that issuing certificate, and you don't actually have to worry about impacting the other tiers of your, PKI infrastructure. So the way that we implemented this, because, ACM internal, right, they do support third-party PKI systems, but going back to how we try to remain as cloud native as possible, we went with, private ACM. What we did for our kind of offline root certificate, again, going back to our micro account strategy, we created an account that was meant for nothing more than just our root CA. So it's literally the only thing in it. Only the security team has access to that, and a small group of our security team at that, right? This account is heavily protected with service control policies, MFA, of course, on the root user, guard duty, security hub. It's all enabled in that account, and it's really locked down. Nobody's really allowed to do anything in there. Our intermediate certificate is then in our protected security core account, which, I don't want to say that it's less secure than our root account, but it's used for more purposes, right? Our security team has various different security tools in it and just kind of has a slightly wider audience, right? But it's still locked down to the security team, still service control policies, MFA still enabled. Our issuing certificate, on the other hand, went into our regional shared services account. What we ended up doing was we used a service called Resource Access Manager to actually share that PCA out to the child accounts. And this allows for application teams to be able to issue certificates and kind of just quickly get what they need to use IAM Roles Anywhere without having to be stuck reaching out to a singular team. The way that we deployed this was with Jenkins And our infrastructure as code choice was AWS CloudFormation. So this was a super seamless process. Everything is coded, everything is version controlled, and the deployment was very easy. It's also worth mentioning that we also have a private CA audit report that has daily updates that's stored in an S3 bucket in our audit account, external to the account shown on the diagram on the screen. Another part of the PCA is the certificate revocation list. So this kind of helps with the certificate status. It allows administrators and end users to be able to validate the status of their certificates. This can be automated on their side, right? They can have cron jobs, they can use IAM Roles Anywhere. I mean, however they want to retrieve that CRL. It also provides kind of, trust assurance, right? When you maintain that CRL, you can effectively communicate the revoked status of certificates to any of the relying parties. Also, a lot of industries, as you guys probably know, they require the use of a CRL, so it's another good reason to have it. Also, depending on how often you pull that CRL down, it does allow for the offline verification of your certificate. The way that we configured this was in our shared services account, in our issuing PCA. We enabled the CRL to do daily uploads of the CRL file to our protected audit account. So that file is getting uploaded to that S3 bucket, which we then use a third-party company called Imperva WAF, to host that CRL for us. So, that bucket policy is only allowing the PCA to upload files to it, and it's only allowing the third party to be able to pull that actual CRL down. I think it's also worth mentioning that as we mature this process, the ultimate goal would be able to go to short-lived certificates, which would kind of make the CRL less important. But for the current state that we're in right now, this is it's working for us pretty well. Another issue that we ran into was the certificate issuing. We didn't want to force teams to have to reach out to a single team or a single person to request these certificates, right? We're trying to automate as much as possible and kind of enable developers to build and get everything they need kind of in a self-service model, right? So what we did was we built a pipeline using Jenkins that deploys a CloudFormation custom resource. Well, let me backtrack a little bit. So the CloudFormation template accepts two parameters. It accepts one CSR as the parameter and one email address, right? So once those parameters are put into the pipeline, it actually goes ahead and it builds out the certificate, and then it deploys a Lambda custom resource. What that custom resource does is it takes the ARN of the certificate and generates it, and then sends the certificate to the user by referencing the email address and the output of the parameter of the CloudFormation file. And this allows our end users to be able to generate certificates on their own without having to reach out to people. It just kind of enables them to do what they need. And it also allows us to not ever have to actually see their private key, right? So they can manage the private key all on their own. So this really helped kind of enable them and speed deployments up. So with that said, I would like to introduce my colleague Rudy to actually talk about the implementation of IAM Roles Anywhere.
All right, thank you, Steve. Hello, everyone. My name is Rudy Trevino, and I'm a senior cloud engineer at Hertz. And I'll be talking about our recent use of Roles Anywhere for a project that we kicked off for our Salesforce workload. So like many large enterprises, we're a heavy consumer of Salesforce. And late last year, we were looking for ways to offload data and ultimately free up storage space. Ideally, we wanted this data to land in AWS and be read back into Salesforce. Luckily for us, Salesforce offers a connector for DynamoDB. And this connector fit our requirements where we just needed to be able to read and write to an external source and read it back into Salesforce when needed. And after testing this connector and several sessions with Salesforce SMEs, we were able to successfully virtualize the data back into Salesforce from AWS. The overall initiative went on to be a great success for Hertz, and the team even got to present the full end-to-end solution at a recent Salesforce developer conference. There was one drawback, however, with the connector, and that was the use of user credentials to connect to AWS. And as you may know, those user credentials are static and they're often long-lived. However, in spring of this year, Salesforce announced support for IAM Roles Anywhere. So on began our transition. So what did we do? How did we transition this workload from using static credentials to roles anywhere-based access? Well, first we had to create a trust anchor. And what this did was establish a trust between our ACM private CA, our AWS private CA, and our Roles Anywhere service. The next two things went hand in hand. We created an IAM role specifically for this external workload and updated the trust policy to reference the service principle of Roles Anywhere. You can use an existing IAM role. However, we chose to create a new role simply to avoid any impact with any other workload or resource that could potentially be using an existing role. That role was then referenced in the profile that we created for Roles Anywhere, and that profile simply indicates which role the service will use. Finally, we created the N-entity certificate with workload-specific identifiers defined. With these things in place, we're able to then create a new external credential in Salesforce and update the connector to now use this credential as role-based anywhere access instead of user credentials. Let's dig into the profile session and also the role policy. The role trust policy, sorry. So on the left, you'll see that we are using an optional profile session policy where, in this example, we are denying all API calls that do not originate from a Salesforce IP. So what we're doing there is we are further restricting access to AWS with this managed policy, and we chose to do managed policy over inline simply for the reusability of this process, this policy, but also the size limitation. As this grows and we expand to more and more regions, this IP list could grow. Also, the role trust policy, we are defining specific values for the issuer and the subject common name. So those values will be specific to the workload. So when I mentioned we created the N-entity certificate, we'll define workload-specific values, and those will be defined here in the trust policy. Moving on to logging and monitoring. So we're using CloudTrail. CloudTrail logs all API activity to and from Roles Anywhere. And then we're also using CloudWatch. So CloudWatch, the metrics we are monitoring are going to be create session counts, both success and failures, and also certificate expiration. So when a certificate is nearing expiration, say 14 days or less, we are alerting to a distribution group via SNS to take action. So looking forward to our use of Roles Anywhere at Hertz, we'll be looking to implement this org-wide. This will become our preferred standard for any external workload needing access to AWS. If the external workload can support it, we'll be looking to use Roles Anywhere. Also, we'll be looking in that org-wide rollout, we'll be looking to leverage Resource Access Manager to share our issuing CA across our 400 plus AWS accounts. Also, AWS Private CA will be assessed to potentially replace our current IaaS-based PKI system. And then finally, we'll be extending the use of both Roles Anywhere and AWS Private CA to all our other regions. With that, I will pass it to Mohammed from AWS. Thank you.
Thank you, Rudy. Hello, everyone. This is Kashk. I am a product manager at AWS Cryptography. It's a pleasure meeting you today. So in the next few slides, I will go over the recent launches, Anywhere, as well as the upcoming capabilities in our roadmap. So in December last year, we released version 1.0.3 of the Credential Helper that allows you to take advantage of IAM Roles Anywhere without the need to do any change on your application code. So what you can do with the release is that you can use the update command where the Credential Helper will go and update and store the credentials that are vended into the AWS credential files, and the AWS SDK will go automatically and fetch those credentials from the standards credential files of AWS. You can also use the serve command that for an IMDS version 2 compatible endpoint on your local host, and the AWS SDK will go and fetch the credential in the same way it does for the EC2 instances. Also, the credentials that are vended using those two commands, you have the option to auto-renew them. What does it mean is that the Credential Helper will go and fetch a fresh credentials whenever the existing one are nearing expiry. Next, how many of you suffered before from an outage due to an expired certificate? Yeah, so we got you covered here. So in November last year, we integrated the certificates that are related to, the events that are related to an expired certificate that are emitted by IAM Roles Anywhere with AWS Health Dashboard. So IAM Roles Anywhere emits two types of those events. One, whenever the certificate that is attached, the CA certificate that is attached to the trust anchor is nearing expiry, and another, whenever the end entity certificate that is attached to your workload that is coming as part of the create session API is also nearing expiry. Prior to this release, to get those events, you needed to configure the Amazon Event Bridge to define a rule for what events you are interested in, and then configure what will be the target on where you'll get those events. However, with this new release, you will get those events automatically on your AWS Health Dashboard without the need to do any pre-configuration on your side. When it comes to those events also, last month, we released a new feature that enabled you first to turn on or turn off those notifications, and also to set the threshold of the notification on when exactly you want to get those notifications. So prior to this release, you didn't have the option to turn it off. And also, it was by default, those events were by default emitted whenever the certificate is expiring in 45 days or below. However, with this release, what you can do, first, you can turn on and turn off those notifications. And second, you can adjust when exactly you want to get those notifications for the best suit of your use case. So, for example, if you are issuing an entity certificate for your workload that is expiring in 7 days, so what you can do is that you can set the threshold for this one into like 2 days, and getting only the notification 2 days before the expiry, which can help reducing the reception of excessive notification that you don't need. Also, as you know, IAM Roles Anywhere is a regional feature, and today it exists in 24 AWS commercial regions at no additional cost. In March this year, we launched also in China region, both of the regions, so CN North 1 and CN Northwest 1. And when it comes to the regionality, I just want to call out one part of it. So IAM Roles Anywhere, as it is a regional feature, so when you call the create session API, you need to specify the endpoint of a region for IAM Roles Anywhere. You will specify the trust anchor as well as the profile that is within this region. However, the credentials that you are getting back that you can use it to access the AWS resources, those credentials can work in any region regardless of the originating request. So in the next slide, I will go over the upcoming capabilities in our roadmap. So by end of this year, IAM Roles Anywhere will be existing in the remaining AWS commercial region, as well as the Gulf Cloud regions, both of the region, the US West and the US East. And going forward, for any AWS new commercial region, you can expect to have IAM Roles Anywhere there at day one. Also, we are working on extending the session validity of IAM Roles Anywhere. What does it mean is that today the credentials that are vended are valid up to 1 hour. However, with this feature, those credentials will be valid up to 12 hours, which can optimize the traffic between your workload and AWS for the renewals of the credential. Very soon, we'll be releasing a new version of the credential helper that enable you to use the X509 certificate and the private keys that are stored in OS-specific cert store, like a macOS keychain or a Windows certificate store, as well as the keys that are stored in an IMDS version 2, in a PKCS 11 compatible security devices, like the HSM devices or the YubiKey, sorry. Also, with this release, you can use the credential helper. You can use the credential helper to delegate the signing process to the keys that are stored into OS OS certificate stores or into a PKCS 11 compatible device without having those keys leaving those stores, which can enhance your security posture as well. Also, we'll be enabling you to get a custom mapping of the attributes that are extracted from your certificate. So as mentioned earlier, the way how it works today in IAM Roles Anywhere, that IAM Roles Anywhere parse some fields from your certificate, like the RDNs that are extracted from the subject, from the issuer, or the send of your certificate, and make them available as a principal tags that you can use them later on for policy evaluation. However, what we got from our customers that maybe the fields that are being parsed today by IAM Roles Anywhere, they are not needed, or maybe they're increasing the size or the complexity of the rules that you define for your ABAC, or even they may be failing the value validation of the STS. So for example, if today you have a comma in one of those values, this is not accepted by STS. So with this release, what we are giving is that first you will have the option to specify what exactly the attributes that you need IAM Roles Anywhere to parse it, so you can use it later on in your policies to control and give access to the AWS resources that will be used by your workload, and also to define the mapping behavior for invalid characters. So those are additional resources for you. I would encourage everyone here to go and explore them. Feel free to take a picture. Also, today from 4 to 6, there will be a workshop session dedicated for IAM Roles Anywhere, where you can learn how to configure and set IAM Roles Anywhere. I would highly encourage everyone who would like to learn more about hands-on experience about Roles Anywhere to attend this one. It is IAM372, consuming AWS resources from everywhere with IAM Roles Anywhere. So in today's session, we presented what is IAM Roles Anywhere and how you can use it, and how you can define the identities of your workload. We also show you how you can use those identities to control access on your AWS resources, and how you can monitor the activities of those identities. Also, we presented how Hertz are leveraging IAM Roles Anywhere to access AWS resources from their Salesforce application running on their premises. And finally, we went and covered the recent launches for IAM Roles Anywhere and the upcoming capabilities in our roadmap. One last thing, the most important thing, I'm quite sure that many of you already attended sessions since the morning. You provided your feedback on those sessions. Thank you so much. Your feedback is really important for us. I would encourage everyone here to kindly go and fill the survey from their mobile app. Also, here is our contacts. Please feel free to take a picture, and feel free to reach out after the session if you have any questions or any clarification. Also, will be available, I believe, couple of minutes here and also outside of the hall after the session. If you have any question, we would love to meet you and speak with you to learn more about any specific requirements or your use case. Thank you, everyone, for coming here today. It was a pleasure meeting you. Thank you.